All right, let's look at section 2.2. We're going to look at some more graphs and displays than what we've already looked at. We're going to start with a stem and leaf plot. Okay, so we're going to design a stem and leaf plot. We're just going to get this one started, and I'll show you on the next page what the ultimate stem and leaf plot would look like. But we have a list of we've got 50 cell phone users, and this is a list of how many text messages they sent in one day. So it's all mixed up, but there's 50 different users. And the numbers go anywhere from 16 up to, looks like 149. Okay, so what we're going to do is we're going to take the first digit or the first two digits. So we're going to line up 1, 2, 3, all the way down to 14. And so for the anything that is in the teens, so from 10 to 19, that's what we're going to put in this first row. So I circled, I think I found the only ones that are between 10 and 19. So I've got 16 and 19. Well, the ones already in this first column, so I'm going to go ahead and let's do green. I'm going to put the 6 and the 9 here. Okay, so this would equate to 16 and to 19. Okay, let's look at the next one. So now we want the 20s. So let's see, I have 26, 29, 23. Ooh, I have a lot. 24, 29, 29 again, 29 again, 26. Oh my goodness, there's lots of 2s. 28, 20. Whew, I think that's it. Okay, now I think they want it in numerical order. So let's see, we have a bunch of them here. Let's look. We had 1, 0, right? Because we had 20. What did we have next? We had a 23, so I'm going to grab the 3. Remember, the 2 is already in the first column. 23, we had a 24, so I'm going to put 4. Let me see. Looks like we had 2 26s. So I have to, for a stem and leaf, I have to put both of those. I've got a 28. And then finally, let me see what I have here. I have 4 29. So I need to put all of those in there. Do you see what I'm doing? So now I can see really quickly how many different numbers I have in the 20s, in between 20 and 29 inclusive. And I can see that there's a bunch of 29s. So then we would do it again for the 3s, we would do it for the 4s. So we do 30 to 39, then we do 40 to 49, and so on. So let's look at the whole chart when it's done. Okay, here's the chart completed. And so again, we see that in the first one, that would be 16 and 19. Let's go down here to, at the 12, that would be 122. Down here at the bottom, that would be 149. So this is just another way, kind of ends up looking almost like a bar chart. But you see a little more information than a bar chart. You do see how many items you have, but you also see how many repeaters you have. So like look at in the 30s. In the 30s, you have 2 30s, you've got 4 33s. And so it just gives you a little different visual look than a table of 50 numbers. All right, let's take a look at this one. This one's working backwards. So this one has, we see our stem and leaf plot here. This is the key. Now notice the key this time, last time it just became a number. There was not a decimal. This time the 1-2 would become 1.2. So right here for the 5, that would become 5.1. Okay, up above would be 4.1, 4.2, 4.2, 4.3, 4.4, and 4.9. Okay, so you have to always look at the key. So they want to know, for this data, which of these things would make sense that this could be the data. So for the first one, it says the highest yearly temperature. Well, 1.2 and 5.1, that doesn't make sense for the highest yearly temperature in a desert. right? In the desert, it's going to be 120 degrees or 130 degrees. So that's not going to work. Then it says time in minutes that it takes a sample of employees to drive to work. Well, I don't think it's going to take 1.2 minutes to drive to work or 5.1 minutes. Well, maybe if you're lucky, it'll be the 5. But these are too small to be that one. Okay, then top speeds in miles per hour of a sports car. No, because that's going to be like 200, I don't know how fast. A lot. These numbers are not big enough. So finally, we have time in hours, not in minutes, in hours spent watching TV in a day for a sample of teenagers. So again, it's probably not big enough, but 1.2, that person has a mean parent. 5.1, they get to watch lots of TV. So the answer is going to be D. All right, so now we're going to look at a dot plot. This it kind of gives you information like a stem and leaf, except because you can see how it's distributed, but you can't actually see the repetition like you do in a stem and leaf. Okay, so this is the same data, those 50 cell phone users. And so you can see you've got the dots here. Oh, we can see the repetition because they put it down to the ones for tick marks. Okay, so all of the data is plotted on here. And so we have two 80s, those go here. Remember, we had a bunch of 29s, those are right here. And so you can see the repetition, but within intervals, it's a little harder to see. So each of these tools shows you a little bit different. It just depends on what point you're trying to get across. So this is actually just plotting all the way from 16 to 149, and you're just plotting the dots on top of each other for however many data entries you have for that number. Okay, so pie charts. We've been looking at lots of pie charts, but let's take a look again. All right, so we did this in the DSMA, but this is a pie chart. We're looking at the numbers of earned degrees conferred in thousands in 2014. So we have associates, bachelor's, master's, and doctoral. We have our frequency here, and then we found our relative frequency. So we added up all 4 frequencies. That gave us 3,805. But then we have to find the relative frequency. So for the first one, we took the 1,003 on top of the total, 3,805, and that gave us 0.264, so about 26%. The next one, we had a frequency of 1,870. We put that over the total, and that gave us 0.491, so almost 50%. And then just like in the DSMA, we know that a circle has 360 degrees. So we took the relative frequency. For the first one, the relative frequency was 0.264. We took that times the 360 degrees. That gave us 95 degrees. Then we took the 0.491 times 360. That gave us 177, and so on. Now, we have tools to do this in Excel if we needed to. But now we have this nice pie chart. You can see, which makes sense, the bachelor's is the biggest. It's almost 50%. That's the pink here. The next biggest was the associates. It was a little more than a quarter. It was about 26%. And so that makes sense. The master's degree was 20%. That's the green here. And then finally, the doctoral. All right, the next chart we're going to look at is called a Pareto. A Pareto chart is still a vertical bar graph. We could use frequencies, we could use relative frequencies, we could use percents. But what's interesting about a Pareto is the tallest bar always goes first, and then the next tallest bar, and then the next tallest bar. So we're not going to go in order of years. We're not going to go in ranking. We're going to go by the tallest bar all the way down to the shortest bar. Okay, so here's an example of a Pareto chart. We're looking at the leading causes of death in 2014. So we have accidents, cancer, chronic lower respiratory disease, heart disease, and stroke. This is kind of depressing. So we're going to take the largest one first. So the largest is the heart disease. All right, the next highest is cancer. So cancer will go next, and so on. The next one is chronic lower respiratory disease, accidents, and then stroke. Okay, so with a Pareto, the largest bar chart always goes first, and then the ranking is you go down the line. Okay, so let's take a look. We have the medal counts for 5 countries of a recent international sports competition. So we have different countries, A, B, C, D, and E, and we want to rank these in order. So we've got to, let's see, we got to see the highest. The highest number of medals was C, so we want C to be the first bar. The next highest is E, and then we go to B. So let's see, looks like it's D because we have C is the highest, and then E, and then B, and then D, and A. All right, we also use what we call a scatter plot. We'll use this more way in chapter 9, but this is just a grouping. So this isn't where you plot the data on a graph and see if you can see trends. Okay, so this is a famous British statistician, Ronald Fisher, and he looked at the Fisher's iris data set. So he was looking at the flowers and he looked at the petal length versus the petal width, and he was looking at this in millimeters. And so you can see by plotting his data that it does basically have an upward trend, right? And so the longer the petal grows, the wider it gets. Makes sense. And that's all because the trend is heading up. So that means that the longer the petal length, the wider the petal is. All right, next we're going to look at what's called a time series. So what's going to happen is the time is going to be along the horizontal axis, the x-axis on the bottom, and then depending on what you're looking at, that's going to be on the y-axis, the vertical. So let's say the amount of precipitation measured each day for 1 month, each day is going to be along the bottom, and then the precipitation level, probably in inches, is going to be on the vertical axis. Let's take a look. All right, so we have a table with the number of motor vehicle thefts in millions and burglaries in millions. And we have our year here. So we're going from 2005 to 2015. And this is just the first column, the motor vehicle thefts. So along the bottom on the x-axis, we have the years. On the vertical axis, we have the number of thefts in millions. And this is a nice, it says time series, but this is like a line graph. And so this is nice because you can see that the thefts are going down. They kind of flattened out, not quite sure why. And maybe they need to work a little more and try to get that down a little more, but it's a good visual. All right, last page for 2.2. So we have a graph here. And they gave us, it's a Pareto, right? Because we've got, the quarters aren't in order. It's not first, second, third, fourth. It's that the tallest bar chart is first, and then it works its way down. We've got quarters on the x-axis, and we have sales in thousands on the y-axis. And it wants to know why this graph is misrepresenting the data. And so one of the choices is that they're out of order, but that's not really a problem because this is a Pareto graph. What's really the problem is, notice down here that it starts at 90. It doesn't start at 0. That graph needs to start at 0 or else it needs to tell you that that's what's going on. So if I redo this graph with a 0 right here and go all the way from 0 up to 130, this looks very different, right? Because in this graph, where the scale is not correct, it looks like the third quarter is way bigger than the rest of them. But look what happens over here with this graph when I go from 0 to 130. Now the bars don't look that different. And so quarter two doesn't look that much smaller than quarter three. And so the answer is that the large gap in the vertical axis makes it appear that the sales for the third quarter are disproportionately larger. Okay, so because the scale started at 90 and not at 0, where it should have started at 0, it's giving a very different picture. Now this happens, and so you have to really watch. You've got to watch newspapers and magazines and the news, especially on TV, because they will try to do this kind of thing because they're trying to get their point across.